Hello friends, the purpose of this video is to introduce the properties of Laplace transform, use of properties of Laplace transform to find out Laplace transform of basic signals. Actually, we can use formula of Laplace transform to find out Laplace transform of basic signals, but this is another way to look at the use of properties to find out Laplace transform of signals. So let's start with the first example where x of t is given as delta of t, which is nothing but impulse. Now we can use some of our previous knowledge that delta of t can be expressed in terms of u of t, that is differentiation of u of t is delta of t. Now this gives us an opportunity to use differentiation property of Laplace transform, which is nothing but d by dt of x of t in if we take Laplace transform of it, the Laplace transform of x of t, which is x of s, will get multiplied by s, and this is what the interesting property we can use. So as we know, d by dt of u of t will be s. This is the effect of differentiation in time, which will be in s domain. The Laplace transform of u of t will be multiplied by s, and Laplace transform of u of t is, that we know, is 1 by s, and this is the effect of differentiation in time. So s into 1 by s, so answer is 1, and that is what the obvious thing is. Laplace transform of delta of t is 1. So this example shows how we can use properties to find out Laplace transform of basic signals. Let's take another example. This is nothing but x of t is equal to t into u of t, which is nothing but a ramp signal. So let's see how we can use properties here. Already we know Laplace transform of unit step is 1 by s. Let's use differentiation in frequency domain. So what's that property? That if you differentiate x of s in frequency domain, that is in s domain, its Laplace or inverse Laplace transform or time domain effect will be x of t will get multiplied by t. And we can, if we know this property, then we can understand from this problem, as here you can see there is a multiplying factor t, that means we can get this x of s by using differentiation in s domain property. So let's see how that can be. So this is what Laplace transform of t into u of t is. This t is going to affect minus d by ds of Laplace transform of u of t, and we know already the Laplace transform of u of t, which is 1 by s, so we have to differentiate this 1 by s, and differentiation of 1 by s is minus 1 by s square, and multiplied by this sign, minus minus will be plus, and it is 1 by s square. So again it is verification of the answer that Laplace transform of t into u of t is 1 by s square, which actually we can calculate by using formula, but here it is shown by using properties. One more problem I would like to introduce you here. Already we have considered t into u of t, and now there is an additional term is coming into the picture, that is e to the power minus t. So already we are well aware of Laplace transform of t into u of t is 1 by s square. We have just calculated in problem number 2. Now let's see how we can use property to get the effect of this e to the power minus t in s domain. So let's find out Laplace transform of e to the power minus t into u of t. That is nothing but Laplace transform of t into u of t, and we know that e to the power minus t is going to affect that change from s is equal to s plus 1. So t into u of t's Laplace is 1 by s square, which is to be evaluated. We have to substitute s is equal to s plus 1, and that is what the effect of e to the power minus t, and that is what the property of Laplace transform. So substitute s is equal to s plus 1, so we'll get 1 upon s plus 1 square, and that is nothing but Laplace transform of e to the power minus t into u of t. So how we can look at this term, and we can also guess what will be the signal in time domain. As this square indicates, there should be a multiple t which is acting on s, and 1 by s that indicates there is presence of u of t, and s plus 1 that means there is a term e to the power minus t. So looking at inverse Laplace also, we should try to get the time domain signal, provided that we should know properties very well. There is an alternative way to work out the same problem. Instead of taking t into u of t, we'll consider the Laplace transform of e to the power minus t u of t. So as we know, e to the power minus t u of t is 1 upon s plus 1. And as it is multiplied by t, we can think of using differentiation property. So t into, what is that? So t into x of t, whose Laplace transform will be differentiation of x of s. So let's use this property to find out Laplace transform of t into e to the power minus t u of t. So that is nothing but differentiation. This is the effect of this t, e to the power minus t u of t, whose Laplace transform we have to calculate. So just we have to find out Laplace transform of e to the power minus t u of t and differentiate it with a negative sign. And we know e to the power minus t u of t's Laplace is 1 upon s plus 1. We have to differentiate it. So the denominator into the differentiation of numerator minus numerator into differentiation of denominator divided by s plus 1 square, that is denominator square. So if we solve this, this term will be 0, and this negative term and this negative term will make it positive, and answer is 1 upon s plus 1 square. So here just you can see either by this property, that is shifting in s domain, or by property of differentiation in time domain, we are getting answers the same. Intention behind this video is to know the use of property and apply them to solve the problem in interesting ways. Thank you.